Unit 5, Writing Classes, Topic 5.8, Scope and Access. We know as programmers that we store data to access, manipulate, and share in creative ways. This topic focuses on access. That means we will explore where variables can be used in the program code. The key word is where. Where variables are located will determine how they can be accessed or used. We will look at local variables and global variables. Note, instance variables are considered global to the class they are in. Here we have a program with variables that exist in numerous levels of scope. Within the class in blue, the only variable that exists across everything else is the instance variable instance var. Because it is declared at the start of the class file, it can be used in all of the non-static methods within that class. At the next level in yellow, we have a method with several variables. The formal parameter x exists from the beginning of the method where it is passed. In green, the local variable local var exists within the confines of the method add. And lastly, in purple, the variable I exists only within the for loop that it is initialized. Local variables can be declared in the body of constructors and methods. These variables may only be used within the constructor or method and cannot be declared to be public or private. If there are multiple variables that share the same name within the same scope, then the variable with the more specific or smaller scope takes precedence. Let's look at an example. Consider the following class definition. In a different class, I instantiate an object, I call the reset method on that object, and I ask to output information. What will be displayed as a result of executing the above code? If you selected C, you are correct. Let's understand why. When the example2 object is instantiated, its instance variable current is set to 10. When the reset method is called, a local variable is declared that has the same name as the instance variable. The local variable current will store the value 20, but the instance variable current will remain unchanged. This is why, when the getCurrent method is called, the instance variable current will be displayed and not the local variable. This example shows the importance of thinking how your machine processes this information and not how us humans see it. Let's look at an example to see this concept in action. A bowling average is calculated by dividing the total pins by the total number of games bowled, rounded down to the nearest integer. A bowling league typically calculates the bowler's average each week or session after the bowler completes a 3-game series. Consider the partial bowler class. We will start by writing the bowler class header, the instance variables, and one constructor. Here we have a public class called bowler with 2 private instance variables called total points and games. It has one constructor that takes a parameter of type integer called pins that will be used to assign the total pins instance variable. As constructors must initialize all instance variables, we need to assign a value to games. In this case, it's been assigned to 3. When there's a local variable with the same name as an instance variable, the variable name will refer to the local variable instead of the instance variable. A common mistake when assigning values to variables is to redeclare them. As humans, we may think that because they have the same name, they are treated as the same. However, your machine will process these as 2 completely new variables that are local, in this case to the constructor. For this reason, you should always call variables that have been previously declared and assign them values and never redeclare them. Let's consider how to implement the method that will calculate the bowler object's average. How might we break down the process of calculating the bowler's average each week? Through method decomposition, a programmer breaks down a large problem into smaller subproblems by creating methods to solve each individual subproblem. What are our subproblems in this scenario? We will need to update the data members to then calculate the average. Let's start by writing our update method. It is a void method as it will be used to update values. It will take in 3 parameters of type integer that will represent the values of pins for the 3 games played. We will also declare and initialize a variable called newPins that will store the sum of the values of the 3 games. The formal parameters and the variable newPins are local to this method. They cannot be used outside this method. Formal parameters and variables declared in a method or constructor can only be used within that method or constructor. We will now update our instance variables total pins and games. Note that we are calling the global instance variables and assigning them updated or new values. Now let's write our getAverage method. We want it to return a value, so it is a non-void method that will return a value of type integer. It will return the total pins divided by the number of games. As these values are of type integer, an integer division will automatically round down to the nearest integer by truncating any possible decimal values. Let's practice with an MCQ-style question. Consider the following class definition. Which of the following is the reason this code does not compile? If you selected D, you're correct. Let's look at why. The variable C only exists within the constructor method. It is local to that method. It cannot be accessed outside of that method. Let's do another question. Consider the following class definition. Which of the following is the reason this code does not compile? If you selected B, you are correct. Let's look at why. Factor is a local variable and cannot be declared as private.